Okay, so we start the morning plenary one session. We have a number of invited talks on sort of overarching issues concerning CORDEX. The first talk is by Bill Gutowski. You already know him. He's from Iowa State University and co-chair of CORDEX.
Okay. Hello again. What I want to do is give an update on where CORDEX stands. If I could have the first slide. Picking up from the history that Filippo gave and raising up a number of issues. I mentioned this morning that there's a lot of discussion I hope we have on Friday, and I'm going to raise some of the issues that I hope you will think about during the course of this week and be ready to make some contributions on Friday. This first picture here shows the CORDEX Science Advisory Team. We had a meeting a year ago in February in Norrköping at SMHI. It also shows in the inset here, Boram Lee is our WCRP liaison, and then Irene Lake, who is the director of the International Project Office for CORDEX at SMHI. Irene, I want to point out, came in as the director just a few months ago and had this whole task fall in her lap of trying to get this meeting organized together, and she's done a tremendous job for her, which we really appreciate. But I also want to point out that it's very important that CORDEX has its project office in Norrköping at SMHI because it's emblematic of the global reach that Sweden has had in regional climate research, for which we are all very appreciative. One of the things we did at this meeting was to review our scientific goals and reassess them and I think come up with a firmer set of scientific understandings that we're trying to attain. So we arrived at this overall mission statement about advancing and coordinating science and application of regional climate downscaling through global partnerships with all of our CORDEX regions around the world. And you all come from many of those regions. And underneath that, we had a set of goals that ranged from trying to understand the whole process of downscaling and relevant regional and local phenomena, the techniques, but also thinking about where what we work with gets used, what kind of data we generate, and how that leads to information that other people may use in other applications. So trying to think of the whole process of why we downscale and all the steps that we need to go through to make sure that we're actually providing appropriate and useful information. Related to all this, we devised a number of scientific challenges that we feel we need to be trying to explore. This is one of the topics that we'll be talking about on Friday morning. So again, I will invite your participation in those discussions on Friday. But we had a very important key element here is assessing just what is the added value of downscaling and its context with thinking about internal variability, metrics to use to measure added value, and what does it mean when we have to do bias correction. The human element in all of this, recognizing that especially on the regional scale, you find all sorts of different ways that human activities enter into climate, regional climate, especially with things like the development of megacities, land use change, and other things like that, in addition to just the broad background of amplification of the greenhouse effect. Coordination of regional coupled modeling, recognizing that whereas the early models, regional downscaling models, focused primarily on atmosphere and to some extent land interaction, that these have become more sophisticated in many ways and also are bringing into play a lot of other different processes, lakes, the cryosphere, in particular ocean ice-atmosphere interactions, and a whole host of other processes that are more and more becoming involved in the modeling process and trying to provide some coordination and understanding of how that proceeds. Focus on a few key areas, precipitation, because one of the strengths that regional simulation, regional downscaling should have is getting those very intense precipitation events that are relevant for understanding extreme events, but also even things that go back to somewhat larger scales, understanding things like monsoon systems, and how those play out in climate. And then also local wind systems, things that global models would not resolve very clearly, but that we hope that through regional downscaling we develop a better understanding. So these are the scientific challenges that we laid out in front of us, and there's a host of questions that we've been developing along those lines, and we'll see more about that on Friday morning. one of the big developments that has come out of this is this development of the so-called flagship pilot studies. This first started to emerge actually at the last CORDEX conference in Brussels in 2013. We recognize that there are a lot of people who are pushing ahead, going to yet finer and finer resolution in simulations, getting down to convection permitting simulations, where you could turn off your convection parameterization. And so we thought we need to try to provide some sort of a framework so that people are actually working in a more collaborative approach to all of this. We identified, so we set up these things called flagship pilot studies that we invited people to write proposals for. We wanted them to have a strong basis in these different characteristics. There should be some kind of a focus on fine-scale processes that are part of the motivation for doing regional simulation. But also, there should be a good observational basis so that you can actually verify that you're doing something that is meaningful and physically correct. And ideally, it has some eye towards user applications, something that can contribute to vulnerability, impact, and adaptation analyses. And even equally important, it would be nice if it had a connection with other WCRP programs, especially GWEX, which these other programs have their own regional initiatives, and so there's a great opportunity to build on what other people have done and work cooperatively in those regions. We had our first call for these flagship pilot studies that closed back in February. We had 9 proposals for flagship pilot studies that the Science Advisory Team was reviewing just yesterday, and I'll say a little bit more about that in a moment. There are other details you can get at the CORDEX website. Out of those 9 that we reviewed, there are 5 that we decided are ready to go forward as flagship pilot studies, and we'll be getting back to those groups with some further feedback, hopefully in the next few days or not much longer than that. It's worth noting that most of these come from the European and Mediterranean regions of CORDEX. That's perhaps not surprising because Europe has been one of the real leaders in terms of really advancing a lot of aspects of climate downscaling and also applications of that. But they're not all from that region. There are 3 others out of the 9 that we want to work with further. We didn't feel they were quite ready to be an FPS, but we want to work with them to develop them further to where we think they could be. And then there's one that we thought might actually fit better with some other CORDEX activity that's related to understanding climate change and providing appropriate climate change information. And we'll be working with the person who proposed that one as well. Another aspect of this is that we have been building a connection with the CMIP program, and in particular CMIP 6. We are now designated as in the CMIP context as a diagnostic MIP within CMIP. The primary CMIP 6 question that we were asked to say which CMIP in our application, which CMIP 6 question would be addressing primarily, and it is this one about how can we assess future climate changes given climate variability, predictability, and uncertainties in scenarios. So we are part of the whole CMIP process now. We are a diagnostic MIP because we are not producing global simulations, but we are using the output from the global simulations to diagnose a lot of climatic behavior. We were also asked to address WCRP grand challenges, one on weather and climate extremes, and at the time that our application went in, there was work on trying to develop a regional climate information grand challenge, although the status of that is somewhat evolving now and uncertain, but nonetheless there is this big issue of trying to understand what regional climate information is all about. And we have been coordinating with some of the other MIPs, primarily the scenario MIP, which is producing the scenarios for future greenhouse gas and aerosols levels, and then also high-res MIP, which is a GCM project to run GCMs at fairly high resolution, generally down around 50 kilometers or so, but a great opportunity for comparing what they're producing versus what CORDEX is producing. Another area of development is that the IPCC has started to express strong interest in what CORDEX can do to provide regional information. As a response to that, we've been tentatively developing this program that we're calling CORDEX Core, Coordinated Output for Regional Evaluations. This, again, is another topic area where we will have a lot of discussion on Friday, and I certainly invite your thoughts on this. As you can see on my slide here, there are all sorts of questions. We are still trying to work through exactly what we want this to involve. This was motivated in particular by this workshop, this IPCC workshop on regional climate that was held in Brazil just last September. The goal of this is to provide a succinct set of downscalings for each region, having a more or less uniform framework for doing this. It's going to be rather limited, I think, in terms of the number of models involved. But the idea is that it would provide a core foundation for additional work that others could do in particular regions. But there are a lot of questions we still have not resolved in terms of how many GCMs we might try to downscale. Which set of GCMs, CMIP5, or would we be able to work with CMIP6 output? And what's future scenario, number of RCMs, statistical downscaling methods, issues of resolution, and some big questions like there are these IPCC special reports that are coming along in the next few years, and how much CORDEX can contribute to those in particular. One report that is supposed to be focused on this 1.5 degree target for global warming. And related to all this, underlying all this, is this other question about how far CORDEX should reach toward climate services. What is the boundary of what CORDEX should be doing as a scientific program, and how far do we go into that gap that you heard about earlier this morning between what the climate simulations are all about and what climate services are all about. We also have recognized that statistical downscaling has not been as prominent as it should be, I think, in CORDEX. The initial foundations of CORDEX were in running regional climate models, but we have had a series of workshops trying to bring statistical downscaling into CORDEX on a more or less equal footing. This picture here is from participants at the first workshop that was held at ICTP in Trieste back in 2013. These workshops had mostly statistical downscaling people involved, and we tried to work towards formulating a programmatic framework that would advance both statistical and dynamical downscaling for producing climate information, talked about coordinating the different comparison of the different methods and trying to discern ways that we can discern what are the advantages of each approach. They both have strengths that they can bring to the table, and we want to understand what those strengths are. And also then the exploration of possible hybrid approaches that combine elements of both. Then Filippo and I were asked to produce a review paper for the Annual Review of Environment and Resources, which focused primarily on dynamical downscaling, but also in the context of the development of CORDEX, and also gave some discussion there of future directions for CORDEX as we understood it at that point. This paper came out last year. There's also another paper that has been submitted to geoscientific model development that is part of the CMIP6 program, in the sense that there is going to be a collection of papers on all the CMIP6 MIPS in this one journal, and we recently submitted a paper talking about the role of CORDEX as we see it as a diagnostic MIP within CMIP6. And then finally, I'm just leaving off with this picture here of the conference. A lot of this has led up to this conference, and it's a way of reminding me to remind you that all these issues that I brought up here, these developments since our last conference in Brussels, are all topics that are guiding our future direction, but they're all things that we want to get feedback from you on Friday when we have these discussions on most of these topics. This is a great opportunity to review where we have come and all the work that we're presenting here, and also to use that as a basis for discussing where we think CORDEX should be going, guided in part by the activities that I laid out here. And with that, I will say thank you for your time and attention.
Thanks, Bill. So actually, we have time for questions from the audience. Again, as we said, a lot of these issues will be discussed, hopefully to a great extent, on Friday. So if there are no pressing questions at this point, we'll wait until then.
Yep.
Okay, thanks, Bill. So we'll go to the next talk. The next talk is by Valérie Masson-Delmotte. She's in the I don't know how enviable position of being co-chair of Working Group 1. We actually asked her to give us a perspective on how CORDEX can best sort of contribute to the IPCC process, especially after this workshop that was held in Brazil last year. Thanks, Valerie.
I'm not sure. Does the microphone work?
Yeah.
Oh, perfect. So good morning. I would like to thank you for this invitation. And in my presentation, I will show where we stand for the preparation of the 6th cycle of the IPCC assessment report, with, of course, a focus on regional climate change. And your involvement as a community, as authors of publications, as potential contributors to the reports is, of course, critical for this point. So this presentation is given on behalf of my fellow co-chair, Pan Maojai from China, and myself. And first, I would like, of course, to stress the specific context for this new assessment cycle and for the focus on regional climate change. We are in the post-COP21 world, and of course, the assessment of climate science is highly expected for the decision-making process for the low-carbon and climate-resilient development pathway. During the last IPCC plenary meeting in Nairobi last month, there was a decision to consider modalities, which means new modalities actually, for addressing and enhancing the treatment of regional issues. And I will next also remind you of how regional issues were handled in the 5th assessment report. We have also the challenge of better integrating across working groups, and especially between Working Group 1, the physical science basis, and Working Group 2, vulnerability, impact, adaptation, and also risk analysis studies. We have an excellent opportunity for close collaboration between IPCC and CORDEX in this cycle. What is the new emerging science that we have to consider in preparation of the next reports? What are the needs from potential end users and stakeholders? And you are at an excellent position to provide feedback on this point. How do you see the scoping of the reports, special reports, but also the main assessment report on this aspect? And how can we work together to engage with the best regional experts in the calls for nominations for participants to scoping meetings or for authors of reports? I would like now to remind you of how regional aspects and especially regional projections were considered in the 5th assessment report. So you see here the outline of Working Group 1. So the rationale behind this outline was to start by observations and paleoclimate context, then process understanding for the carbon cycle, for aerosols and clouds, and then the physical understanding of changes, radiative forcing, evaluation of model, attribution of climate change, and then near-term and long-term projections, and finally, integration for sea level aspects and for climate phenomena. There was also an atlas of global and regional climate projections, which was mostly based on CEMIP 5 global projections. And there was a regional annex also in Working Group 2, consisting of 10 chapters. I've tried to highlight in red the chapters where there was at least a mention of regional projections, downscaling. Of course, it is highly relevant for the study of cloud processes. It was addressed in the chapter on model evaluation, weakly considered for detection and attribution, weakly considered for global projections, partly mentioned for regional components of sea level, and for climate phenomena. So I think we have really the challenge of better using information from climate downscaling in the next assessment report. Here, I would like to introduce you with the Working Group 1 Bureau that was elected last year and the Technical Support Unit of Working Group 1. Unfortunately, I will not be able to stay longer here. I have to go to Bonn this afternoon. But Wilfran Mufumaokia, Wilfran, can you stand up, please? So Wilfran Mufumaokia is the head of science in Working Group 1 Technical Support Unit, and he will be here until the end of the week, which gives excellent opportunities for discussion. So the head of the Technical Support Unit is Anna Pirani. She works also at ICTP in Trieste. and they will both contribute to the work of the Bureau. So the Bureau members from Algeria, Argentina, Canada, Morocco, Indonesia, Norway, and Pakistan can also act as regional contact points for those of you who would like to exchange and discuss with respect to the work of the IPCC. I also would like to mention that we have open calls for positions in the technical support units, one for operations and one for IT. If you have good candidates, don't hesitate to circulate the call to them. Now, what is the timeline for the special report? As was mentioned previously, the first special report of the AR6 cycle will be the invitation from the Paris Climate Agreement. So a special report will be delivered in September 2018 on the impact of global warming of 1.5 degrees above pre-industrial levels and related global greenhouse gas emission pathways in relationship with the global response to climate change, sustainable development, and efforts to eradicate poverty. And these words are also important. So there will be regional dimensions. How much can CORDEX contribute to this assessment? What will be available in time in peer review publications will be quite critical for this aspect. There will be a methodological report on greenhouse gas inventories from the Task Force on Inventories for early 2019. We don't yet have fully developed the timeline for the two other special reports. One will address climate change and oceans and the cryosphere. There will be, of course, requirements for regional information, especially, for instance, for coastal areas or regional components of sea level change associated with glaciers and ice sheets or regional oceanic changes. And the last special report that was decided during the last plenary meeting will be on various land use issues, including desertification, land degradation, sustainable land management, food security, and greenhouse gas fluxes in terrestrial ecosystems. The exact focus of these two special reports will, of course, be defined during scoping meetings, but there's no doubt that regional dimensions and relationships between climate change and impacts for land use and food production are quite critical here. A few preliminary considerations for the sixth assessment cycle. For the main report, the scoping will take place next year, in about 1 year from now, and the outline will be prepared for approval in the plenary session of autumn 2017. The final step of the AR6 cycle is the approval of the synthesis report. It is planned in 2022, also as a component to inform the global stocktake set up by the Paris Agreement in 2023. For Working Group 1, the approval is scheduled between the end of 2020, the beginning of 2021. We still have a small uncertainty there. What's important to also know is that the sequence of reports will be changed. In the past, it was by numbering, Working Group 1, and then 2, and then 3. But in the fifth assessment cycle, there were some difficulties to ensure a coherent assessment, especially on regional climate change and impacts, across Working Group 1 and Working Group 2. So it was approved that we shift the order, the sequence of Working Group reports, and the sequence will be 1, 3, and 2. And this allows more time for the research community working on impacts to use the same projections as used in Working Group 1. We want to involve more authors from developing countries and economies in transition and need to find the best way to engage with these authors. For instance, you can find on the IPCC website the contact points for the IPCC focal points in each country, and these are the persons in charge of circulating the call for nominations. It's important to be in touch with them. For the structure of Working Group 1 main assessment report, it will of course depend on the scoping meeting. But a few considerations are that we have to cover from global to regional aspects and strengthen the regional assessment. We want to be driven by process-based understanding, very much in line with the grand challenges of the World Climate Research Programme. We will have a stronger focus on extreme events, including attribution. It was not covered in detail in the AR5 because there was a special report on extreme events. This time it will have to be covered in depth in the main assessment report. And we are still considering various options for addressing regional information. For instance, an option could be having a standalone regional report as a new product across the different working groups. But no decision on this point has yet been done, and this will depend on the scoping process and how convincing we can be that such a new option will strengthen the regional assessment. I'll give just 2 recent examples. This is from the American National Academy of Science report on attribution of extreme events, where you see the level of understanding of effects of climate change on different types of events and the confidence in the capabilities of attribution. And of course, we expect developments in this way with a stronger role of regional modeling, as these conclusions depend, of course, on the capabilities of climate models, the available observations, and the understanding of the physical mechanisms at play. My second example is with respect to relating global mean metrics with regional change. There's emerging knowledge on this issue, and on purpose, I did not choose examples where authors used regional models, but I used examples based on CEMIP 5 projections. One example is the relationship between change in extremes, these are the warmest extremes, in relationship to global mean temperature. The example here is for central Brazil, and of course the projections go above the 1-to-1 line, showing a nonlinear relationship with regional extremes. The second example is an assessment of the fraction of global land area, showing change towards drier or wetter conditions. Will these assessments be supported by the contributions from regional modeling? How about the way processes related to aerosols and land use changes will be combined? These are important topics for consideration for science developments and for what will be available for the AR6 and special reports on these topics. For instance, these projections were performed using the RCP 8.5 scenario. What about lower end scenarios, RCP 2.6, coherency use of aerosol and land use aspects in these low carbon scenarios? This is still a quite open question. It was also mentioned that we had recommendations from an IPCC workshop last year in Brazil on regional climate projections and their use. We also had an IPCC workshop on communication for climate science 2 months ago in Norway. And I picked up 4 key conclusions, 4 key recommendations. The first one is, of course, to prepare the assessment of climate projections using multi-model and multi-method ensemble, method also meaning statistical and dynamical downscaling. How can CEMIP and CORDEX best contribute to the AR6 together? The second point is to develop a coordinated assessment of uncertainty in climate projection along the whole modeling chain, from climate change projections to projections of impacts and risks, which is quite critical for end users and goes together with best practice guidance. The 2 recommendations from the communication workshop were to consider stakeholder and end user needs in scoping. WCRP is an observing organization to the IPCC. It is consulted and it will be consulted, for instance, for pre-scoping of special reports or the main report. And through this channel, it is possible for your community also to contribute for the different scoping consultations. And the other point is to develop the communication skills of authors and involve communication experts, including social scientists, which we are very carefully considering very early at this stage for the AR6. So we have tools. We can co-sponsor. We can organize expert meetings and workshops to foster coordination. We can also provide guidance documents on good practice to facilitate the assessment process. And on these various issues, I think guidance documents will be highly needed for coherency assessment in the AR6 cycle. So we have prepared a few topics for discussions together with Wilfran. And a few of these topics are, for instance, what are your recommendations for the AR6 to bridge the gap between science and practice using regional climate projections? What will be the CORDEX contributions to the AR6? What are the lessons learned from downscaling the CEMIP 5 projections? What will be the timeline for downscaling the CMIP6 projections or for the low-carbon scenarios? What is the status of progress towards a common benchmark for exploration of uncertainty in regional projection and risk analysis? How complementary can be CORDEX, climate services, and IPCC assessments of regional climate change to best make use of the various bodies and the various integration of these three components? And what will be the future directions and priorities for regional climate projections in the context where, within CMIP6, there will be high spatial resolution global model projections? I'm available for your feedbacks and discussion on these various points. Thank you for your attention, and looking forward for a very constructive collaboration in the coming years. Thank you.
Thanks, Valérie. Actually, you can see here many of the topics that we will discuss during the week. So I'm going to open the floor we have plenty of time for questions. In fact, we are quite ahead of schedule. So let me see if there are first some questions from the audience. This one here. Carol.
Thank you. Is it on? Thank you. Thank you very much for this update as we're trying to reach a better understanding how we can benefit from CORDEX and the RCMs being developed. I work with the United Nations Economic and Social Commission for Western Asia, and you'll be hearing a little bit later about this. I'm very interested in the scoping report and identifying which regions might be identified. And if you could elaborate a little bit, if this will be a demand side or supply side approach to identifying those regions where your focus will be placed. There are the traditional ones, and there are ones that maybe are more politically demanded right now because there is not as much information available. And I'm just wondering again, is that just at the scoping meeting, or if there would be other means to benefit from work being conducted? And in that light, are you only using peer-reviewed outputs in journals to identify what those regional outputs are, or are you generating work yourself to feed that report process?
Okay, so for the IPCC report, it has to rely on peer-reviewed publication and open access data related to the peer-reviewed publications. So that's the first step. It's, for instance, possible to replicate a figure with some update, provided that the methodology has already been published. This is one example. But the key is to provide on-time peer-reviewed publications if you want a research question to be available for the authors if they want to address that question. And the second point was about the choice of regions. So I think my fellow co-chair from Working Group 2, Hans Pörtner, in a few minutes will also mention that, and he will remind you of the way regions were considered in the AR5. So I think this will depend on the scoping process for each special report and for the main assessment report. The two ends will be considered, I think, and they could be case studies suggested. This was, for instance, the case for the SREX special report on extreme events. During the scoping process, it was explicitly defined which case studies would be considered based on existing knowledge.
So just before we go to the next, follow-up to this. So based on the timeline,
yes.
What is the due date for papers?
So papers to be accepted for publication.
In Working Group 1, of course.
In Working Group 1, they have to be accepted for publication approximately 6 months before the approval date. For instance, for the special report on 1.5, the approval date is September 2018. So papers that will be cited in the final version must be approved before March 2018.
And for the
main assessment report, if we have an approval, let's say, by end of 2020, it means June 2020 or something like that.
June 2020.
So this gives a very stringent constraint on the use, for instance, of the new scenarios of the CMIP6 timeline.
So the target for us is at most June 2020, if we want to be in the... Okay. So remember this date.
This is why I mentioned the approval sessions, actually. I had that in mind. Thank you.
There's a question here.
Hi, I just have two more or less related questions about the kind of scenarios you're going to run for the next IPCC report. There's some, the last 2 or 3 years are showing up a few papers about the resilience of the climate system to zero emissions and the effects of geoengineering. So I really, probably I missed that part, but I really didn't see that in your presentation. My question is, are you considering those? I mean, there's a very new path about the geoengineering solutions. Actually, the Australian situation right now is pretty much related to that. So what happens in the IPCC with this and also with this other path about how the climate system responds to zero emissions?
So I didn't mention that because IPCC is not developing scenarios. This is, for instance, done within the scenario MIP from the WCRP. There's a special issue from CEMIP 6 that includes a paper describing, I think it's one of the EGU journals, online journals, Geoscientific Model Development or something like that. Yeah. So the papers are online. There's one for scenario MIP, and basically the new scenarios will be parallel to the RCP ones with 2 additional scenarios, one with an overshoot and then a strong decrease of emissions, and another one that is not yet available that will be a low pathway compatible with 1.5 degrees, so it will be a RCP 2.0 scenario. And there will be also an update of the RCP 2.6 scenario, which, given emissions of the last 10 years, is less compatible with 2 degrees than it was 10 years ago. So that's one part of the information. So you asked about geoengineering in different ways, I think, and the response of the Earth system to that. That also will be explored by CEMIP 6, especially considering the climate carbon cycle feedbacks. And there's growing literature on rebound effects, where when you have negative emissions, you can reverse the sign of fluxes between the ocean, the land surface, and the atmosphere. So there will be new simulations to explore these aspects. And for the discussion of the 1.5 degree special report, we might, depending on the scoping, consider geoengineering, and we will certainly consider negative emission technologies because they are explicitly accounted for in low carbon scenarios.
In your presentation, you spoke a lot about climate change, projection, future climate change, and how CORDEX could contribute to that.
Can you say again?
I didn't understand.
Yeah, there's some echo or something.
Yeah.
So in your presentation, and specifically in the last slide, you spoke a lot about climate change projection and how CORDEX could contribute to that. But in the community, there are also a lot of studies about climate phenomena understanding or regional climate phenomena understanding, specifically using regional climate model in the evaluation mode driven by reanalysis, and also a lot of studies about past climate trend attribution.
Sure.
So what is your point of view about the role of CORDEX on this first chapter of the working group 1, about the climate phenomena understanding and trend attribution?
So, of course, one key point is understanding observed changes. This is what you stress. It belongs also to detection and attribution. And this is also, for me, a question on how much regional downscaling can contribute to that in complement to reanalysis and high-resolution simulations, global simulations. And any feedback on this aspect is really appreciated. In the last IPCC assessment report, especially in the detection and attribution chapter, there was very limited use of regional modeling for this aspect. I believe that for the attribution of extreme events, for instance, there should be a very strong contribution from understanding of processes at play at the regional scale, combining observations, physical-based understanding, and simulations. And this is what I meant when I referred in our design of what could be the next assessment report on the importance of process-based understanding, which for me combines observations, statistical analysis, physical processes, and modeling together. The way to do that is not yet fixed. It will depend on the scoping. Many of the Bureau members of Working Group 1 suggest that it's time to change the structure of the Working Group 1 report, but this will depend on the scoping process.
Maybe I have a question on this, on the structure of the report. I know it's early because things need to be discussed, but I have two questions. One is, do you expect that there will be like a regional chapter similar to chapter 14 or to chapter 11 in the fourth report or something? And the other is about the atlas. You know, there's been a lot of discussion about the atlas. Some people felt it was not an entirely useful exercise, for at least from the application side. And in Brazil, there was a lot of discussion about what do we do instead of the atlas? What type of product? Should it be a web-based product? Whatever.
Yeah.
Well, can you, since I think CORDEX can play a role in this, if you can give us some idea of what type of product you're kind of thinking about, or if you're thinking about any type of product.
So what I tried to express is the fact that together with Working Group 2 and some aspects of Working Group 3, we think it would be timely to integrate across working groups and have a sort of regional reports that would be a regional synthesis across the process-based aspects of Working Group 1 and the sectorial aspects of the main assessment of Working Group 2, for instance.
So
that may incorporate, if it is approved to have a new product like that, then it would rely on Chapter 14 of Working Group 1, and then the regional annex of Working Group 2, and the atlas together in a synthetic approach.
So this would be the regions as they're defined in the Working Group 2 AR5, like Africa,
This is to be defined. It might be similar. If it is not approved by the IPCC Plenary to have a new product, or if it does not come out of the scoping process, then we will strengthen the regional assessment within Working Group 1, but I don't see that as being restricted to just one final chapter. I see it more personally at this stage to be covered in each aspect, like global energy budget, global drivers, and then dynamical aspects linking global to regional aspects, processes at the regional scale, acting in extreme events, etc. So I would not see it as being restricted to just one chapter, as in the AR5. I would see it to be strengthened, and this would allow also to include more regional experts in various chapters of the AR6. And with respect to the atlas, your feedbacks are very welcome. I read with high interest the outcomes of the Brazil workshop and the recommendations. I think it would not be the best way forward to just keep the same atlas and having a Working Group 2 atlas in parallel. We need to be more creative and to meet more the end users' needs, as you stressed.
I have a question here. When the CMIP6 projections are going to be available, it seems to me that the timeframes are like very constrained to have a CORDEX downscaling based on CMIP6.
I understand that CMIP6 simulations are starting to run now, and they are planned until 2017, basically, and they are more or less on time. I don't see the AR6 to be restricted to the use of CMIP6 simulations, and I stressed lessons learned from CMIP5. There's still a lot to be learned from CMIP5, and the pathways will not be that different. So I think we need to find the best way to combine information. If you look at the AR5, it used CMIP3 and CMIP5 projections, so we need to do the same. And clearly, for instance, CMIP6 simulations will not be available for the first special report, which will mostly rely on CMIP5 and additional sensitivity simulations from new projects such as HappyMIP, specifically designed for that one.
So let me ask a blunt question. If you were to, I mean, a big discussion we are having inside for the next phase of CORDEX is Do we wait for the CMIP6 simulations to be done and then we do our downscaling, or do we take a bit more time and do it with the CMIP5? What would be your recommendation?
What I really tried to stress is some of the key questions, I think, from end users are, how will regional impacts be related to the global stocktake, to the state of the global climate system, to like global mean temperature, cumulative carbon emissions? And this can be explored using existing simulations. It has started to be done in some regions like Europe. It's going to be done in others. And I think that's highly relevant for the IPCC.
So even using CMIP5
Sure.
will still be a good option. Okay,
sure.
Thanks.
Hi. I have a question.
I don't see
where is this voice coming from?
Yeah, from Beck.
Okay.
Yeah.
There's a light, so we cannot see.
Okay.
You have very kindly mentioned about the technical committee from different countries. So I want to ask a question that how you can mention their responsibility and what sort of contribution we can to contact with those technical committee members from a specific country in respect of CORDEX community.
I'm not sure I'm the right person to answer to that question.
I didn't listen, actually. Can you say the question again?
It was about the resolution available for...
When you showed the TSU,
yeah.
you showed the... this one. You have mentioned the technical community members, and you also mentioned that we should, if we have some sort of question or some sort of contribution, so we can contact them with their related. So what sort of responsibility these teams have, and what sort of contribution you are expected from the CORDEX community in this regard?
Okay, so the technical support unit is providing technical and scientific support for the Working Group 1 Bureau and for the authors of the report. They are preparing the scoping meetings, and they will do their best to facilitate the work of the authors. Amongst the duties are having a monitoring of the state of knowledge, being aware of what is being developed is highly important. So, for instance, informing them of new publications would be very much appreciated so that they can follow what is being developed and what is available for the assessment.
There is a pretty good coverage, geographical coverage in the Bureau. So there's one question there.
Hi, thank you very much for the presentation. It's concerning maybe about the first question, data transparency. You mentioned that it will be good to have open access to the data. Are you planning some kind of guidelines or use some kind of platforms? I have seen some work that they use GitHub, for example. You can have access to data and do again the analysis. So are you planning some kind of guidelines? Thank you.
These are the exact things that need to be developed. For IPCC reports, at least, we have the duty that everything is transparent. So any conclusion has to be supported by references and data. And I would very much suggest that, for instance, data used for figures of the IPCC reports could be provided to curious people outside of the community. This was done for the summary for policymakers only last time. But I think we can do that better now.
Is this a strict recommendation?
No, but we have this duty of transparency. Yeah. And I think more and more publications can also provide key data and software in addition to the publication. So we have tools to develop that.
Yeah, many journals actually require that you make available your data.
And CMIP6 data will be also of open access. Many of the observations, at least some of the final products, are also open access. So I think it's extremely important for the IPCC to also strengthen this, this part of the transparency between the conclusions and the underlying data.
Okay. Any more questions?
On
okay.
The fourth line.
Oh, here. Sorry. Oh. There is a question here in the fourth. Right here.
Okay, thank you. Just you said the focus will be in the new coming IPCC report will be on the impact, using the data in the impact study. My question is, in the impact study always we need to use the bias corrected data, and unfortunately all this data available in open access, and also for CORDEX data, it's raw data. It's not bias corrected. So do you have any plan, to include bias corrected data in future report, or everybody need to do it on his own? Or?
This is exactly where we need the expertise of the authors in order to make the assessment so that the best quality data and the best practice is explained. And I think that Hans Pörtner from Working Group 2 will continue to develop these aspects, especially because of the focus on impacts on adaptation for Working Group 2.
Any more questions? Actually, I have another question is, you mentioned the issue of aerosols and land use.
Yes.
And so there would be, because in the past, these issues, especially within the framework of the projections, were not really treated very well, I would say, or in great detail. Will there be more emphasis on these in the next report?
If there's more emphasis in the scientific developments and in the publications, there will be more emphasis in the report, because the reports depend on what the communities, the research communities are providing. But at least what's really important is ensuring coherency between boundary conditions for regional projections and what's covered in scenarios. So that's a very important point, especially given if you consider low carbon pathways, then land use aspects may be very important drivers for regional climate change if global radiative forcing is limited.
Right. Yeah. Okay. Okay. I don't see any hands up, so thanks very much, Valérie. This was very, very useful for us.
Thank you very much, and please feel free to exchange with Wilfran during the end of the week. I'm sorry I have to leave now. Thank you.
Okay, thank you very much. So I don't know how we're going to proceed for the remote. We are 5 minutes ahead of time. Is somebody contacting Hans? Oh, I need some technical help here. He's there. Hans, can you hear us?
I can hear you, yes.
Okay, good.
Thank you.
So thanks very much. So just a brief introduction. Hans Pörtner, he's the co-chair of Working Group 2. So we asked him to give us some perspective of how CORDEX can actually contribute from the, let's say, Working Group 2 perspective, even though I can see there is a more integrated one now. Thanks, Hans. Go ahead.
Can I speak now?
Yeah.
Okay, thank you very much. Well, I will take my earphones out because there is some feedback, and I think I should focus on my talk now. Well, thanks anyway for reaching out to the Working Group 2 of the IPCC. And I would like to join Valérie, and first of all, thank Valérie for the general description that she has been making about the IPCC processes and the decisions made. And in your discussion, you've already touched some of the critical points. Now, our Working Group 2 in the IPCC is addressing vulnerability, impacts, and adaptation, and thereby incorporating regional approaches. Because in a way, you can say that all impacts are regional. And when we do so, we consider regional climate trends, and that certainly relies a lot on information that comes from Working Group 1 and also on associated impacts, those that have already been observed and those that are projected. And detection and attribution is certainly an important element in that process. So we look at specific drivers and their effects, but also consider combined effects, because that usually there are cases where this exacerbates the effects of climate change. We consider extreme events and their impacts, and also certainly the vulnerabilities and the risk levels, and loss and damages to be considered in the context of climate change. The socioeconomic background has to be considered as far as it concerns human systems, and also adaptation potential, and last not least, the impacts of adaptation measures that are meant to avoid the impacts of climate change but may have their own impacts. And these will certainly pose some ethical and not only climate-dependent limits to adaptation. The mitigation potential has the same issues. There are impacts of mitigation measures, and especially if you think of it in the context of bioenergy and carbon capture and storage following after that, that would have huge impacts on land and on the land surface area used, and that will pose questions with respect to the respective limits. Now, when we talk about regions in the context of the assessment report, and looking back on the AR5, the special report on extreme events, then that is where really we've had the highest resolution with respect to regions reached. Whereas in the Working Group 2 main report, we had then 10 chapters which were mainly focusing on continents and subcontinents. So focusing on geographical areas is a possibility, but in AR6 we might also consider climate zones, and there are specific climate regimes and scenarios, and all of this would have to be discussed in the scoping process. What I wanted to highlight here is that AR6 has a more of a focus on the low emission scenarios, and that it will be very important in the AR6 to compare impacts under different climate scenarios. And then this is an example here from a recent modeling studies where the authors have been able to identify significant differences between impacts under 1.5 and 2 degrees C. And these 1.5 and 2 degrees C, as you all know, are the long-term global goals that are being discussed currently in the negotiation process. In a way, that kind of language is a little different from what the language that we usually use in our scientific communities, which makes it important that we bridge and reach out to them and that they understand what we are talking about. And you see that all of these impacts, where they see these significant impacts, are again regional. Mediterranean with a stronger drought to be expected under 2 than 1.5, or heavy precipitation being expected in South Asia. And there are certainly global issues as well, like the global sea level rise. And then again, the coral reef example is one which, if you consider it by latitude, would be a regional one, and otherwise, if you go across the globe close to the equator, you might also look at it from a more global perspective. And then there are effects on crops that also show some differences. The authors come up with a relatively strong statement where they say the additional 0.5 degree increase in global mean temperature marks a difference between events at the upper limit of present-day natural variability and a new climate regime, particularly in tropical regions, which in a way, although all of this information needs to be assessed in AR6, it emphasizes how important it is to look at these low emissions scenarios and really trying to make and understand the differences between them. Now, going across these scenarios and considering these numbers that are being discussed in the context of the long-term global goals, one approach that helps us to understand these differences is to assess the level of risk associated with climate change. This was done in AR5. There are some open questions for AR6. Once again, the low emission scenarios have not been fully covered and compared. But the focus on risk is certainly one that we should be maintaining in the R6. And key risks are those relevant to Article T2 of the UNFCCC, which demands that we should avoid dangerous anthropogenic interference with the climate system. And you see these risks here differentiated being the present, the near term, and the 2 degree and the 4 degree temperature target, telling you immediately that the resolution that we have in the Information War Working Group 2 may, in some cases, be somewhat less than the resolution coming out of the Working Group 1 activities. There's also the issue of adaptation. Adaptation can be used, especially if it comes to human adaptation, to reduce risk. But this adaptation has its capacity limits. So risk cannot be reduced indefinitely. And you see here schematically for a 4 degree future world, risk reduction by adaptation may actually be quite limited because adaptation capacity in itself depends on climate change. The near term may bring us close to an estimate of how a 1.5 degree world would look like. And what we should also be considering is that the potential for mitigation in reducing risk, because the potential for mitigation may also be limited, and there may still be some residual risk to be considered. Now, this risk is being depicted and assessed by the famous burning ember diagram, which is a sort of a charismatic element of the Working Group 2 report. And you see here the most recent version of it, like we have it in a recent paper under review or accepted, close to accepted for Nature Climate Change. And you see these global issues, but again, if you look at the risks that are being addressed here, all of these examples comes from the region. Biodiversity, coral reefs, Arctic systems, mountain systems, heat waves, extreme precipitation, agriculture, Greenland ice sheet, and so forth. And these can be and have been distributed here across these risk categories, like the risk to unique and threatened systems, where we will see more examples, or the risk associated with extreme weather events, and so forth. So this kind of risk approach has been rather successful and should certainly be maintained. And now there are also efforts to attribute the level of confidence to them, to what degree and with which level of confidence we can really make these assessments, many of which rely on expert judgment. These burning embers have led us during the so-called structured expert dialogue between 2013 and 2015 to compare the long-term global goals, and they actually evolved to provide a nice language to do that, to bridge out to the UNFCCC negotiating community, talking to them about whether we should go for 1.5 or a 2 degree world, and what does it mean compared to the other worlds. And here you see again the UNFCCC Article 2 requests that we should allow ecosystems to adapt naturally, ensure that food production is not threatened, enable sustainable economic development. And these kind of statements would set the framework for the risks that we were identifying. Talking about the key risks of impacts or those avoided impacts that could be avoided under in a lower emission world. And walking you through some of the summaries that we made would illustrate sort of how we can then approach these these risks in the different climate worlds. For example, in the present world, or the world that we have just left behind, because we are certainly above 0.8 degrees currently, we have observed species displacements. We have seen constraints on crop production arising. We've seen forest diebacks due to drought and heat. And we've seen some unique systems at moderate to high risk. And a very prominent example is certainly the warm water coral reef systems, where these systems here goes from healthy, shown on the left-hand side, to one that bleached, turned white because it lost its algae that provided the energy to them, and then into one where these bleached corals could no longer recover, and the reef turning essentially into a desert with much less and reduced biodiversity. What we must say that this certainly is the system that is the most sensitive. The Great Barrier Reef has already lost half of its live coral cover since the 80s, and this year especially, you see an aerial photograph here, is characterized by large-scale bleaching events associated with the El Niño event. Certainly, temperature is not the only driver to be considered. There are other influences interfering, like predators that may benefit from climate change, or increased intensity of extreme events like storms. So if we go to a 1.5 degree world, these changes will certainly exacerbate. But there is a range of considerations where we can say, okay, climate change velocity is slow enough so organisms can actually move and follow their preferred temperatures. Some coral reefs may remain intact, although the fraction of those may be actually relatively small. Sea level rise may remain below 1 meter. Some Arctic summer sea ice, which is under threat, as you know, may remain. And ocean acidification in a 1.5 degree world impacts may remain at moderate levels. But we will certainly see an increase in some of the risks that we are already presently observing. Capacity to increase food production may be reduced, and some unique systems like the coral reefs may be at high risk in a 1.5 degree world, with up to 90% of the reefs being in danger. And the risks of combined ocean acidification and warming become more prominent. As an example for this, for the challenges and the risks involved, here's one depiction taken from the synthesis report on the risks associated with sea level rise. And what the figure clearly shows on a long term, by 2300, that if we succeed to remain in a 1.5 degree world, we may have a chance to keep sea level rise below 1 meter. Although I think there are some uncertainties about the contribution of the Antarctic ice sheet, and these numbers will likely have to be revisited in the AR6. And if we then go to the 2 degree world, there we can no longer really distinguish avoided impacts from projected impacts, because many impacts become widespread. Climate change velocity may become too high for some species to follow. Long-term sea level rise may exceed 1 meter, with the respective consequences for coastal habitat, flooding, seawater inundation. Arctic summer sea ice may be lost. Some unique systems are at very high risk, and risks of combined ocean warming and acidification become high. And crop production would be at high risk, with still some room for adaptation. All of this should tell you that you should be motivated to look at these low emission scenarios, and the practicalities, like the question of feasibility, should certainly be in the room, but it should not stop us looking at this, because the impacts that we observe and will observe in the future will be the ones that motivate action, and we need solid scientific information on these issues. And an example for a 2 degree world for widespread impacts actually would be coming from the human sector, where there is an increasingly unevenly distributed risks across the globe, especially due to impacts of crop yields and water availability, as well as increasing inequalities between populations. There will be shifts from transient to chronic poverty with social marginalization and food insecurity. And there will be risks from heat stress in various areas. Elderly, children, the socially marginalized, and outdoor workers will be suffering under extreme heat. That's what we can already say from AR5, and we certainly need more specific and more quantifiable information than to be used, hopefully, in the AR6. But this is, again, a scenario which previously has been thought to be rather benign, and that has led the negotiation process for much too long, as we've heard earlier in the introductory session to your meeting. Now, when we go across the full risk scale and then consider the long-term global goals, one aspect I wanted to flag is that we need to consider the combined impacts of climate drivers, like in this case, ocean warming and acidification on ocean organisms. Because you see that the risk transitions, if we just look at ocean acidification, that the risk transitions will move to much lower, in this case, atmospheric CO2 levels, which would be related to that risk in the ocean. And finally, to take this and to summarize this as an example to be considered maybe in the context of the global stock take that will be starting with the meeting in Bonn this week, we have compiled here the information that we have for the oceans by sort of doing this circular risk depiction, again, from yellow, moderate, to high, to very high risk, and then drawing lines between these different sectors in the oceans, going from organisms on the left-hand side, the blue colors, to ecosystem services, like coastal protections on the right-hand side. And these polygons that you see reflect sort of the degree of temperature change that is depicted here, associated with present-day RCP 2.6 or the INDCs, which according to Climate Action Tracker would lead us to 2.7, or according to Climate Interactive 2015 estimate would even lead us to 3.5. And then certainly the business as usual scenario, RCP 8.5. And you can clearly see, except for the present and the RCP 2.6, and except for the high-risk situation for the warm water corals shown here, all of these other projections are pretty much in the high to very high risk areas, telling us and providing motivation to the political process of global stocktake and also then to the respective mitigation efforts. And this is, I think, at the core of what Working Group 2 should do in this context, is provide the solid scientific information for motivation of the measures to be taken in the future. And for that, certainly we need to, and let me re-emphasize that, need to consider the UNFCCC and COP requirements. We need to differentiate scenarios and associated impacts and risks. We need to identify the transition to dangerous climate change, and we need to consider limits to adaptation mitigation capacity, as well as consider sustainable development targets. Linking the regional to the global context in this context is really important, because these negotiations, these global negotiations, will rely on these simplified measures of long-term global goals and on the cumulative emissions. So providing motivation and guidelines, building on the Working Group 1 efforts, complementing them with the Working Group 2 insight on impacts, adaptation and vulnerabilities is important for the global stocktake, and then will lead the mitigation efforts. And this way, by bridging towards the language used in this negotiation process, we can bridge towards the discussion of the long-term global goals. With that, I would like to close, and thank you very much for your attention.
Thanks, Hans. We have maybe time for one or two questions. Maybe I will ask the first question. From your presentation, it looks like there is much more emphasis on the low-end emission scenarios. In CORDEX, we always had this discussion as to should we do a high-end or low-end scenario simulation. You know, of course, the high-end shows more the climate change signal, but maybe for the impacts, do I understand correctly that from the sort of impacts point of view, it's better to go towards the low-end scenarios if we were to choose?
I think my response to that question would be we need to put them into the picture. We need a comparative view of the low-end scenarios. And my understanding of the Working Group 1 situation is that we need better statistical information about how climate and how regional climates will evolve in such low emission scenarios, because that information we certainly then need to put into relation with the impacts that will also be mostly observed at regional level. So I think, and I would encourage you to develop a high ambition to improve our understanding on the low emission sides and also on the sensitivity of climate regimes to the changes and so forth.
Thanks. There's a question here from Dave Carlson.
Hi, Hans. It's Dave. It's fun to have this conversation back and forth. You know, we do it all the time. What I think is interesting and what's useful for what you've shown us is this sense that we can tease out or clarify the impacts, and I'm glad you focused on the ocean impacts because I think those are crucial. But if you heard our discussion earlier with Rolf this morning, that seems to lead us as far as wisdom, but it might not take us the next step toward action, or because we have to overcome an emotional barrier. As Bill said, we have to work in a different value system. So I know that all of IPCC, but especially Working Group 2, wrestles with this question. How do we take what we consider wisdom and actually convert it into useful information? So your comment on that would be, I'm sure, helpful. Thank you.
Yeah, thank you very much. That is really touching a very important question. How do we understand the present societal inertia in terms of addressing climate change? And I can see this psychosocial background as being one that needs to be addressed in the next report. And we are preparing, envisioning that, and hopefully that will also be considered in the scoping process. The more distant we are from the impacts that are being observed, the more difficult it is for us to rationalize, to realize, and to develop the kind of motivation that we need to take action. And this anthropological and psychological background, I think, is poorly understood. We have been seeing a long period of compiling scientific information, but not developing any political action, and this gap, I think, needs to be bridged. And the scientific community, in the adaptation world and also in the psychosocial sciences, they can certainly make a large contribution to address these issues.
Okay, we are rapidly falling behind schedule. It's my fault, but so if there are no more questions, thanks very much, Hans. This was very informative for us.
Well, thanks a lot for having me.
One last question. There is a pressing question somewhere. I don't know where. I see the microphone moving, but I cannot see where it's going. Oh, Tim Carter, there you go.
Right into the middle of the auditorium. Hello, Hans. Tim Carter. Yes, thanks very much for a very informative presentation. I was struck by the use of global metrics, which of course are very useful for informing policymakers in a simpler way. For example, the use of obviously global mean temperature and the impacts associated with that. But I was wondering if we maybe would need to use somewhat more sophisticated methods, even at the global scale, to incorporate a couple of things that I think the burning embers diagram wasn't able really to capture over the different iterations that we've seen of the burning embers. One of those is rates of change. You mentioned that yourself, but so how rapidly would we actually approach these global mean temperature targets? Do we have an overshoot? Do we come back at some point, or are we... because I think that also raises some questions for the climate modelling and sort of what the trajectories are, and also regional climate responses as well. And the second aspect to that is the level of vulnerability of society over those time periods as well. And that begs the question on, well, what sort of assumptions are we making for, this is for human systems. I accept that the physical systems maybe are somewhat divorced from the socioeconomic context, although the drivers are from socioeconomic context, but certainly the human vulnerabilities are going to be socioeconomically conditioned, and so that also begs a question as to what sort of information we need about future socioeconomic development. And again, it comes down to a sort of regional perspective on that, and I'm wondering what your thoughts are on how we might try to represent that in the AR6 process, and how researchers should be treating this as well, because of course we are seeing a lot of new studies being initiated now, and there's a new scenarios framework in place. But I'd just be interested in your responses to those two issues.
Yeah, thank you very much. That was covering quite a range of issues, which are all very important. Some of them really touch the Working Group 1 activities and the present efforts to improve on the regional climate modeling side. I think is very important here, and also the efforts to improve on the shared socioeconomic pathways and on the regional impact modeling. And Valérie and I have already been exchanging views on how we could try and bring this together. And this is, I appreciate a lot that there is a strong increase in motivation in the Working 1 community to address the more regional aspects. As far as your considerations of rate of change and whether overshoot or not, and the practicalities, I think there are many open questions. Maybe we need a much better consideration of what is feasible over time, and also how much impact can we allow, how much recovery may be possible from impact after such an overshoot. These are all things that are not very well developed, and I would love to see the research community looking at this in more detail, because this is certainly information that would also be important for policymakers at the regional level as well. So I think we have made progress, and we are about to make progress, but we are not yet there. And the combination of regional climate modeling and impact studies is a very important element in that context. That is what I can say at the moment. Thank you.
Okay, I think we need to move on. Thanks very much, Hans.
Thank you very much.
So we go to the next speaker, Bruce Hewitson University of Cape Town. He's worked a lot on the interface between climate and end users.
Thanks.
Thanks, Bruce.
So I'm stepping away from the big institutional, big picture frame and thinking more about what's happening on the ground and how CORDEX relates to that. Particularly in the context that the more I'm intimately involved with CORDEX, the more I try and step outside CORDEX and think about how it's been seen from outside of CORDEX. And the view from outside CORDEX is often very different from what we think it is perceived as. So things are changing rapidly, research is going on, but decisions are being made on the ground at the same time. And this parallelism of the research and the decision and actions is a problem because the research is ongoing and we're trying to operationalize research. So I've just picked up a quote from Christiana Figueres from last week's Rotterdam meeting, which I think was quite powerful. I don't know how strong it really is because she said it quite quickly, but she says the insurance sector has already said the world that goes above 2 degrees is systemically uninsurable, which is quite a dramatic statement. And the question I would ask in the context of the operationalization of what is actually ongoing research, especially with CORDEX, what is the information on which we need to decide? And this is an ethical epistemic problem. It's ethical because it's a value-based issue, and it's epistemic because how do we know what we know? So there's an information question here. And disturbingly at the conference, there was a number of people promoting their data products, and this one, I won't give who said it, but said, we take care of the data hassle transparently. Spatial and temporal grids of climate projections are harmonized, biases and variables are corrected to make the data directly usable. If that doesn't scare you, it should. But that is happening in the real world at the moment. There's this hunger for this information. And I'm leading a big international consortium on the intersection of climate change and cities. And again, how do you get the information for a decision maker at the city scale that is actually credible, defensible, and actionable? And that is a real problem. And we can't wait because people will continue to make decisions. So the problem in a long sentence, as I would capture it, would be we have a dominance of a linear supply chain. In other words, core physical science trickles down all the way through to the decision maker, which is chasing high-resolution regional information, where next users, not the end users, the next users, usually overinterpret what's been passed on to them. And it's usually badly communicated, and very often the data is contradictory. It's provided by a plethora of portals with no guidance on how to select from one or the other. Usually self-authorized boundary organizations have little or no accountability, making big leaps of assumption, and using an ambiguous language set. Now, uncomfortable as that is the reality of what's out there and what decision makers are faced with. CORDEX sits within this landscape and has, I would argue, a responsibility to think about how it engages with this complex landscape. So the decision maker sits with this context. They sit with a host of non-climate stresses that they're trying to balance out. They're trying to get observations which are often absent. There are many GCMs who have no guidance on how to select them. They have the hard-to-access RCMs. They have high-resolution empirical statistical downscaling with implied skill, which isn't necessarily there. And, of course, a host of other spatial disaggregation techniques. And the decisions are going on amidst this complex flow of what people like to call information, but often is noise. And CORDEX does not have the sole responsibility to address this problem. But I would argue strongly that CORDEX has a responsibility to step into this problem because you're part of the solution and can't be disengaged from this. So I would identify 3 gaps around CORDEX because the presence of CORDEX in the landscape, there are some gaps that we can identify. Firstly, there's the interface gap where every one of us is a next user of something that's been fed to us, and we feed things on to next users. We have a responsibility in how we engage at these interfaces. And that's complicated because our community is typically in a sort of positive mindset where it's empirically based evidence, whereas we're often speaking into a decision community that is a value-laden community that has rejected the positive mindset in many cases. And that tension is real and existent, and we need to learn how to talk through that interface. Then there's the concept gap. Language and terminology is highly ambiguous depending on who you're talking to and what their background is. And I would pick up just a few ones here, particularly regional information versus information for regions. Regional information is often used to presuppose a higher resolution is a higher skill, and we need to target and drill down into that resolution issue. Whereas information for regions is about saying, well, I know something about El Nino and the global modes and how that impacts my region. I know something about the synoptic scale that impacts my region. In other words, I can draw the information from a multiplicity of scales and bring that to bear on the decision scale. And that leads to the idea of a decision scale rather than a target resolution. Higher resolution isn't necessarily the decision scale. The decision scale is a complex function of the system that you're speaking into. And so on. There are a bunch of language issues. That's not an exhaustive list by any means. But thirdly, I would want to really focus on now on the analysis gap. So the one gap is the analysis of the CORDEX runs. So we do the CORDEX runs, the data comes out, often the data just gets written up in one paper, and there's a need to analyze it in more depth. We've talked about the process-based approach, the necessity to understand the process dynamics basis of what we're seeing. But I think CORDEX is reasonably good at that, and that's getting better. But the second gap analysis is often filled by a needs-driven approach. A user has indicated they need this particular variable or this particular product. And so we go massage the data, we produce the product, and it gets shoved out the door. That's often a naive approach, and it addresses the perceived ends of the needs and not often does that very well. And the third one I want to focus on is what I would call the tailored information through the lens of a system complexity. So the decision scale is trying to address thresholds of degradation, thresholds of failure in a complex interrelated system that we don't fully understand. And what we are trying to do really is get to an information product that is tailored to the scale of the decision that is needed. That is what we would call the distillation dilemma. And the distillation dilemma is because of this. We have the observations, we have the circulation dynamics, we have the GCMs, and we have the downscaled products. And those do not converge always. In fact, they often contradict. And so how, from the lens of a decision maker outside CORDEX, do we speak into this context where we have complexity of information streams and bring something that the decision maker can responsibly adopt? Here's just one example from a paper I was involved with a few years ago. We're just showing there 3 of the CIMA-5 GCMs in the top scale. It's looking at an eastern coastline of South Africa. It's looking at a target region, that little green area there, actually where Mandela grew up. And the GCMs all say drying, of varying degrees, but they're also drying. And then the RCMs, an RCM embedded in the GCM, gives you slightly different messages. And then the statistical downscaling gives you another set of messages. And if you look over there, our GCM says drying over the area, the RCM says coastal wetting, the statistical downscaling says drying. But come to this model over here, still drying in the GCM, drying in the RCM, now wetting in the statistical downscaling. What do we make of that? We can't just put the data out there. That is abdicating our responsibility to think about the fundamental reasons for these contradictions and disagreements. It could just be natural variability. It could be something else. It could be bias. It could be error. We need to unpack that. So the distillation idea says we want to build rigor and robustness. We want to integrate multiple resources predicated on understanding why they look the way they do. Secondly, we want to assess the influence of the errors and biases. The errors and biases are there in the models, in the downscaling. We need to understand to what degree do they impact the message that is interpreted out of it. And then thirdly, approach this through the lens of a use case. In other words, not from a meteorologist's perspective, but say, there's going to be a use case at the end of this. How does that look back at this data, and how does that frame our interpretation of the data? So just to give you an example of how awkward it can be at the moment, we did a survey from the Working Group on Regional Climate about the IIV community, and we asked them a bunch of questions. One of them we asked is, what were your criteria for accessing the models? And the majority said ease of availability. Okay, so that neatly tweaks a problem. Then we asked, how many models did you use? And still the larger group said we used one model. Okay, so we got the most available single model. Then they asked, is the spatial resolution sufficient? The biggest group again said, no. One model, ease of access, and it's not sufficient for my resolution. So what do you do then? Then most of them did their own downscaling. That is, in practice, what's happening with some of the IIV community out there. Again, cause for concern, because in part the situation exists as the physical climate science and modelers are not stepping into that dialogue and engaging in that realm sufficiently. So let me give you an example of a distillation. I'm going to focus on the city of Johannesburg. This is from a paper we're preparing that looks at Johannesburg and Copenhagen as two contrasting places about ways to approach distillation. Focus particularly on the top left-hand panel. That is the historical trend from observational stations around the city of Johannesburg. And you can see the error associated with them, but dominantly you get a message that in the December, January, February season, the summer rainfall, convective season, an increase historically of rainfall, marginal, it's not a totally absolute message. This is no strong topographical forcing, so it's a strongly convective-dominated summer rainfall region. If you look at the GCMs, top left-hand panel, for the grid cell co-located over the city of Johannesburg, and remember we're trying to speak to a city decision maker there, so we're looking at the city, the GCMs are pretty much all over the place for December, January, February. If you look at the RCMs, just looking at 6 RCMs run within the CORDEX framework, again, no clear, solid message there, but a message that's different from the GCMs. And you go to statistical downscaling, and the statistical downscaling gives you yet another message, and this one happens to say wetting during December, January, February. Which is tempting to say because historically it's wetting, this must be right, but that's not necessarily true whatsoever. What do we do with this mix of information? And this information is going out and being used by the impacts community. So here is somebody who's using the CORDEX data to look at the hydrological state of the land surface. In this case, they're looking at the net irrigation requirement under a future climate, and this information is being fed into policy and decision making. That's disturbing. So we need a process-based assessment of this mix of data to try and filter and distill out of this information a fundamental physical basis for why we should focus on one particular message versus another message, or understand the differences in message. And we sit in a context of multi-multis, as I would call it. Multi-models, multi-methods, multi-scenarios, multi-observations, et cetera, et cetera, et cetera. And you could probably add more on there as you like. Let me give you a quick example of one way we approach it. For those of you who know self-organizing maps will recognize this. If you don't know self-organizing maps, don't worry. Just imagine that if you just aggregate all the possible states of the atmosphere into archetypes, this is an array of the typical archetypes that you'd see. The big blown-up one is 850 hectopascal temperatures. Top right is specific humidities on the same level, and bottom right is the winds. And what we're looking at is the archetype states. And you can do a number of things about this. You can say, how often do these different states occur in the past, and how often do these states occur into the future? We're looking at the process-based, the spatial temporal behavior. We're looking at how the system moves through that space in time. We can map out a basic behavior of the spatio-temporal dynamics of the system relative to a region. So here's one example. So each of these little gray squares is one of those nodes, is one of those states. And we can look at where does January on average fall, where does February on average fall, where does March on average fall, and that is the seasonal cycle in that state space, the atmospheric dynamic state space. And the black arrows are the historical trends. So you can see December's moving slightly towards where January is. January is moving quite strongly towards February. February is moving down towards where March is. We can look historically how the evolution of these states is trending, and these, of course, are the states that determine the experienced climate at the surface. So it gives us a good physically based perspective on that. Now we can apply that to the models. So the red line is the observed seasonal cycle around this state space. It's the same in each of these panels. Each of these panels now is a different GCM. The blue line is the GCM's trajectory through that state space. And you can see some models are really peculiar. They really miss a whole lot. Other models are quite well in some places, but they miss some of the extent of the seasonal dynamics. And we can start interpreting model by model where they're missing out in some of the spatio-temporal dynamics of the processes that are driving the surface. And you can rank them. So we just happen to use an index here called the Heligan distance, which is a nice index of looking at distributions. And you can say in the Heligan distance, 0 is a perfect match, 1 is an imperfect match. It goes from 0 to 1, and you can start ranking the models. Now, what do you do with that? You could weight them, you could exclude them, you can do all sorts of things. But one interesting question is, what if you look at the change of message as you add progressively more and more inaccurate models into the system? And you get this. So if we look at the blue curve here, this is December, January, February. This is one model, the best model, A. I've taken the names away so you don't worry about that. And then as you add 2 models, as you add 3 models, 4 models, 5 models, as you go up, you start seeing a little bit of a change in the message. Not a strong change, but certainly the highest, if you include just the highest skill models, you get a stronger drying message than you do if you add in all the least skill models. And these ones are really bad up over here. and you can look at that in the other seasons. So you can start building a mix that is process-based informed about how the message should be distilled out of this situation. You can do exactly the same to the RCM. So here's 6 RCMs from CORDEX. And again, the red is the observed seasonal cycle through the state space. The blue are different different RCMs. And you can again rank them. They're not a strong ranking. They're all of comparable skill there. And you can start again looking at how the message changes. Now, if you take the grid cell precipitation over the location of interest, city of Johannesburg in this case, you can start seeing that if you use just the highest skill models, you get a wetting signal. And as you add the less skill models, that wetting signal declines. And that gives you a basis for digging back into the models and saying, what is causing that? What are the dynamics in a particular model that gives us this changing message? From all of this, you can start building up a picture of what's actually going on. So we could say, historically, there's a trend to wetter. It's a fairly strong message. We can look at the state space and looking at the shift of the seasons, and they are shifting towards a stronger midsummer synoptic state on average, historically. So that would give us a message of perhaps conducive to synoptic forcing or towards a wetter state. The GCMs indicate a drier summer by grid cell precipitation, but we know in a highly convective regime without strong constraints on it, the GCM grid cell convective rainfall is going to be somewhat suspect. The RCMs, on the other hand, give us a wetter summer, and we would expect that a higher resolution in the RCM would give us a better capturing of the convection. And the statistical downscaling, likewise, says we're getting a wetter summer. So we can start at a very limited level, this is still work in progress, starting saying there's a physical basis for interpreting and understanding what the future may look like in this location without going to ultra-high resolution downscaling, and from a mix of messages, give us a physically explained reason for perhaps we can expect wetter midsummer conditions in that region. There's a probability we can put to that. And so you can look at the other seasons and other parameters. So just close on this. Developing methods, I think, appropriate to the source of building understanding about information for regions is where a major research frontier is sitting, and CORDEX needs to be engaged in this. Secondly, how do we understand the contradictions between what the CORDEX models produce and what we get from other sources of information? We need to understand the physical basis for those contradictions. And then more on a practical note, we need to manage the expectations. As we've heard this morning, there are huge expectations of CORDEX feeding into a number of scenarios or a number of contexts. And then lastly, encourage you as an individual to think about where are you in this next user network. You have a next user and you are a next user, and thinking about how you're engaging on those interfaces and how perhaps you can evolve your engagement on those interfaces. Thank you. I presume we're out of time?
Is there a couple of questions?
Sir?
I don't know. Yeah, I think we have time for a couple of questions.
Hi, Bruce. I think you would count me one of your most loyal listeners because I've heard versions of this talk many times, and I see the increasing skill. But I hear two messages, and I wonder if they convey this regional to global difference. On the global scale, I hear a very clear message that says, with CMIP 5, we didn't get that much improvement over CMIP 3. So I call that a convergence message. And it implies that whatever effort we put into CMIP X, we're not going to, from you, I hear what I call a divergence message that, look at, we have all these products and they give us a divergence. So is this a difference between the global scale and the regional scale? Is it an indication? But my second, so I'm curious about that, and maybe we don't have an answer. But my second, my basic feeling is the barn door's open, this horse is run, okay? And the idea that the user lens is somehow clearer or more higher fidelity or more focused than the other lens has been proven wrong. That the users in a changing climate, their needs are evolving, their skills are evolving, their idiosyncrasies are evolving, whatever. And so whatever techniques we take, elaborate statistical, high-level ensembles, if we go into your multi-world, are we actually going to gain? Are we actually going to gain anything when our users are? I mean, they're receding ahead of us, I think, and I'm not quite clear whether we're going to catch up with them this way. That's my fundamental question.
So if I can take that in reverse order, I'm not arguing that the user's lens is the right lens. What I'm arguing that the user lens has perspectives that us in the physical climate sciences don't fully understand or comprehend always. And they're important perspectives. Likewise, I think the user communities, the decision makers, don't fully understand the lens with which we're approaching it. So there are values added to take both perspectives. And we need to understand both perspectives because they inform on how we make our final interpretation of the messages that are communicated. In terms of the GCM regional or global to regional, I think there's not a contradiction in terms there. I think it's more a case of understanding the limits to where the signal to noise ratio sits as a function of scale in time and space. And so, yeah, there is a convergence on GCMs on the global modes, on the global scales, but there's still that divergence as you come down to the regional scales within the GCMs.
Yeah, just one super quick question. I just want one word from you. If I was to ask you, based on your experience, what is the minimum number of models in your multi that you need? One number. I want one word.
One sentence.
One word. A number. If
I'll give you a sentence. The minimum number is those number of models that can actually capture the spread of natural variability. I don't know what the minimum number is.
You're
because
a chicken.
It's scale dependent, it's location dependent. We've had this conversation for a long time.
Okay, thanks. We can go to the... Thanks very much, Bruce. To Daniela Jacob, the director of the German Climate Service Center. I think I got this right.
Yeah, thank you very much, Filippo. Let me see if I can find what I have to find here. Okay, thanks a lot. Let's assume we solved the distillation dilemma for a moment. Or let's assume that we need to take decisions, as Bruce said, anyway. With whatever information is available, there might be a good idea to somehow look at what is CORDEX doing when we talk about climate services. So last night I thought, actually, this is a nice title for a nice paper in a new journal. So this is the advertisement minute here for you. There's a brand new journal called Climate Services, and it is a scientific journal reviewed, and it has a speciality in it. All the papers have to have a section called Practical Implication. And I think this is a very important part because it asks the authors to think about the message they want to give with this scientific method or activity to practitioners. On the other side, it has the potential to increase the knowledge and to decrease the confusion on the practitioner side. So we probably end up with a paper like this, and in case you're interested in writing such a paper, you can contact me, but don't send me an email, please. So, let's talk a little bit about climate services. The European Commission has developed a roadmap on climate services in order to help to establish a global market of climate services. And since we heard a lot about CORDEX, we now should wonder what actually is a definition for climate services. And I personally like to refer to what the European Commission's definition is, what you see here. And it is a bit lengthy, but I would like to take you through this because it says a lot. It is a transformation of climate-related data. That's what we heard about just before, together with other relevant information, could be sectorial, could be social, could be economic, into customized products such as projections, forecast, information, trends, assessments, counseling on best practices, development and evaluation of solutions, and any other services. They are targeting 3 major areas with climate services: support adaptation, we talked about this morning, mitigation, and disaster risk management. And if you look into this, it is very clear that climate services talk on very different scales. They go from, I would say, short predictions like weather to centennial scales. They go from local to global. They are cross-discipline. They cross sectors. And it is something which is really very variable in different regions of the globe. So what are examples for this? You all know about heavy rain and flooding. There's, of course, a little problem here, and we might end up with a change in the drainage philosophy of what we had today. So the question is our current infrastructure able to cope with changing weather events? It might be the energy infrastructure, as these where damages are due to a connection of specific hydrometeorological variables. So we heard before today the combination of situations is of interest. So how do we know where this happens and how often? There can be major damage due to erosion and track melting when we see, as we see here, in May 2013 or in July 15, where this very, very local damage was caused. Roads, we have here a nice example of a flooded road in Sweden, in southern Sweden, or we have a heat problem with material. So I picked here, of course, by purpose, very local things which people are asked for. How should we work with this? What do we know about this? And I think that it is CORDEX which can help here a lot. So what we need for adaptation is to connect the global information to the local scale. And you can do this through global simulation, regional simulation, and so on and so forth. And here already you see that what we heard from the IPCC talks this morning, that we have a combination between local and global communities and development of those interactions. But we go even further. So if we look at cities, at the urban developments who have to adapt, then the information does not end at a kilometer scale, which we hopefully be able to address relatively soon. We might have, for the city-adapted urban development, we need information, for example, from CORDEX, which I think is a perfect source for this, to develop even smaller scale information to give and help with basic, solid, and scientifically solid information for spatial planning. Here I see a chance for CORDEX to get involved. So let me sum this up a little bit. Requirements of decision makers are usually, and I focused, of course, on CORDEX too, so a little bit, I'm not repeating what we discussed over the last years. So the demand is for very high spatial resolution, very high temporal resolution, especially when it comes to landslides, heavy precipitation induced, for example. There is the need for robustness of the information, scientifically solid and explainable behavior. We just heard this from Bruce. We should know why the signals are different if we use different ensembles. And we have to end up somehow with these multis, so from whatever we need here. This, of course, is a bit demanding on us. So users need climate change information on local levels. You can probably do this on your own. I mean, you can develop local detailed climate information. You develop your non-hydrostatic models. You use all your weather models which you use. You can do this on a single institute's level. The simulation need to account local feedback. You can also do this on your own if you like. But I think the second point here, the statement of the robustness of the information we have, here we need a community. And I think that is why I think CORDEX is perfect to be connected to climate services when we come to those multi things. Because everything I showed you is extremely demanding on both on the community effort and on the computing time which we need to understand and simulate these processes and to do the projections. So I think it is not doable in an isolation. We have to have a global effort here with regional expertise and emphasis, and I think this is where the connection between the regional climate services and the regional CORDEX activities is a perfect match. So EuroCORDEX, for example, you know about it, we just changed a little bit our philosophy in the structure. And we had a meeting in January, and I just wanted to point to you the change in the organizational structure here. We have now 3 pillars on which we would like to further work on, and those are empirical statistical downscaling and dynamical downscaling. Both of these have the individual research and development questions inside. Both have to work in their communities, but in order to understand what they are telling us, the climate information, it can be nicely done in a joint effort. So we have now 3 equal pillars here within EuroCORDEX in our organizational structure, which have, as I said, parts in each pillar which can be done in more or less isolation. And we have some of those which are cross-cutting, where we really see a benefit in bringing the communities, the statistical and the dynamical downscaling and the expertise of analysis and bring this together. And this, of course, can be done in flagship pilot studies. This was developed at the latest General Assembly of EuroCORDEX, which we hosted. And here I think it is very clear that the emphasis will be on higher resolution and additional components. That's what we consider in EuroCORDEX as being important for the next 5 years. So now we know what CORDEX can do and we know the requirements. Now we need a common concept for CORDEX and climate services. And I think the concept of next user, the next user's chain, would be a nice concept for these 2 communities, the climate service community and the CORDEX community, to work together. And you could see that whenever I was talking about CORDEX, I was using a blue color. And you see here, this is of course only a part of what we can look at, but for some examples, you see in these next user chain, the providers which can provide information to the next user, who can be a provider, could be an end user, and so on and so forth. And in each of these steps, and here are some parts, there's, I would say, a significant amount of where climate services can benefit from the CORDEX community and the scientific work, which is done in a more or less coordinated way in CORDEX. We can start in the measurement simulation with reanalysis and climate simulations, in the data processing, of course, the ensemble philosophy you see. I show you a figure, and then I'm almost done, Filippo. So I'll show you a few more examples. Then we come to the climate information here, and then we come to the product, where I think there we have to discuss how far is CORDEX interacting in this last box. I would say CORDEX should stay out of this for a moment, but this will be discussed over this week, I guess. So I show you 3 examples for typical products and related to these boxes here for climate data processing, climate fact sheets, climate information, and then for media and Outlook. And so one possibility, of course, and this is what is being done, is to use or to develop from the multi-model, multi-scenario ensembles from CORDEX, EuroCORDEX, and national contributions to CORDEX, site characteristic climate fact sheets We have developed this together with a partner, which is a large industrial company called BASF on a chemical medical area. So these are tailored products, co-designed and co-developed with users. Here I would say it is an end user, because they wanted to have this for themselves, but it's not fully clear, because one of their CEOs might only get part of this information and would be a next user of the information we delivered. And another product are the climate signal maps, where a robust statistic is behind to find out in which regions changes might be there. So easy, understandable, but scientifically solid information is needed for climate services, and this is really asking for a large effort in the climate community, in the climate science community, and even more in the CORDEX community. And the last one I want to show you is I want to remind you that could be kind of a web atlas. So there are many, many different ways to design products and to design or to fulfill users' needs and demands, and we really have to be careful not to be too demanding on the user and say, okay, this is what we can offer and you have to understand it. So products are very individual in different regions, for different purposes, for different level of practitioners, and they have to be developed very individually in a dialogue effort. This is a huge effort ahead of us, but I think it will help understanding. So how can CORDEX help these climate services? We hope to discuss with you on Thursday in session D1, where we would like to see how CORDEX activities and climate services needs are matching, and also expectations from the climate service side. And we would like to exchange your experience with what we have learned here in this room. It will be an interesting exercise. We have about 100 people coming, and a World Cafe doing with 100 people type discussion will be interesting. But I hope to see you there, and let's continue the discussion on Thursday. Thanks.
Have been threatened because lunch is getting cold. Yeah. So I will have to postpone questions to, I'm sorry, lunch is getting cold, I'm told, to the session D1, but I'm sure this will raise many, many issues. Thanks very much, Daniela. We go to the last presentation by Carol Chouchani. She's the Chief of Water Resources Section of the United Nations Economic and Social Commission for Western Asia. Take your time.
This is unfair. You messed it up, and you can't.
I realize I'm between you. Can you hear me? I realize I'm between you and the lunch, so if you'll bear with me 10, 15 minutes, what I'd like to share with you, and I think it's very appropriate to present this at the end of all the interesting presentations we just had, is actually a case study how we can use CORDEX to actually operationalize this science policy interface. And we're all complaining how this research work can actually feed into the process. Interestingly, how we started our work on the regional initiative for the assessment of the impact of climate change on water resources and socioeconomic vulnerability, RICCAR, was actually through a demand-driven process. And ironically, CORDEX was developed in 2009, and the first time that the Arab Ministerial Water Council met was also 2009. So we've grown up together, and I'd like to share that experience with you, and perhaps give some lessons learned from that. in the Arab region, climate change is a new topic that we can say publicly. Let's be very honest. The first intergovernmental declaration that was issued in the Arab region on climate was just in 2007. We could not say it in a resolution before that, and I work in a regional commission very closely with the League of Arab States, where it was taboo. But in the last 5 years, 7 years, 10 years, and we're now reaching next year 10 years after the declaration, we're able to see a lot more movement on this topic, which has generated interest not only from the climate community, but also from the water community, the foreign policy community, the agriculture, metrology, and planning community, both at the regional scale and at the national scale. So we're seeing an acceleration of this, and this is largely actually because of the work we're doing under RICCAR with CORDEX protocols being adopted. But just some background, what is RICCAR that we are talking about here as a case study? Well, it is a regional initiative between United Nations organizations and League of Arab States agencies, along with technical experts at the global and regional level, SMHI being a very core part of that. And the aim here is to provide information to inform a common platform for informing climate change assessment, adaptation, negotiations, and even mitigation. And we're doing this to help support conversations at the Arab regional level, as well as priority setting and positions. And this is implemented with 11 implementing partner organizations. You can see they're quite varied. Collaborating institutions over time have contributing information models to the process, and I'm happy to see several of you here. And this is supported by the Swedish government as well as the German government. So what is RICCAR? Well, what we've been doing for the last 5-6 years is looking at 4 pillars. Developing a knowledge hub for the Arab region, for the Arab states, conducting an integrated assessment that links dynamically downscaled models with vulnerability assessment, building the capacity and institutional framework for doing that, and of course, raising awareness. And what I guess is most interesting for all of you here is how we are pursuing this integrated assessment, which takes, again, regional climate modeling and actually uses that to inform regional hydrological modeling, which feeds into vulnerability assessment and integrated mapping outputs. So this is the domain that was set up under CORDEX. But we were preparing this, actually, while CORDEX was still being set up. And what's interesting about this is that it's the first time that we are able to generate outputs at the Arab regional level. If you can see, the Arab region runs from Morocco, Mauritania over here, extends to Egypt and Sudan over here, with Djibouti also, and the Arab Gulf, and going up to Iraq. Comoros is always also part, but it's excluded because you can use basically the African domain for that. But what's interesting when we were setting this up was several things. First, we've already heard about the work of the IPCC. Well, in AR4, we were disaggregated into 5 different regions. It was very hard to get any conversation between the Gulf and Morocco going. AR5, a little bit better. You know, there's some collection there, but still we're chopping off part of the West Asian part from the rest of the Arab region. It's understandable because they are different climate areas. I mean, even the WMO divides up their regions this way. However, it doesn't work when you're trying to use a political basis to information to inform the political work that you're doing. Even the regional averages that came out didn't really help us if we wanted to have an Arab-level conversation. So basically, again, with the help of SMHI leading an ensemble task force and work conducted an analysis with ACSED, UNESCO, COW in Saudi Arabia, I think COW might have been involved as well, and ESQA and the support of CETA, we looked at various ways to set up a domain for the Arab region and tested various ideas. What's interesting, though, is that the setup of this domain and the sensitivity was politically motivated. Which is a little bit backwards when you think of the climate research. We wanted to see what happens to the headwaters of the Tigris, the headwaters of the Nile River, what happens with the ocean forces that were creating a cyclone Ganu in Oman. And so therefore, this Arab domain that fits now within the CORDEX, we started our work in 2011, but it became the MENA domain under the CORDEX umbrella in 2013. It's much bigger than what you would say an Arab region is, but it allows us to consider all those exterior forcings that affect our region and provide, therefore, data sets where a Morocco and Mauritania can speak to an Iraq and a Oman in the same conversation. We also adopted the CORDEX way of deciding which scenarios. Don't forget, we were working in 2009. Everyone was still talking about SRESs and all this in our work. So we had a lot of conversation as to which scenarios would work, and we adopted the ones that are generally used under CORDEX. I will have to say, though, that our UNEP colleagues wanted to go down to that 2.6 scenario, and maybe we should have, given the conversations that are happening now with the 1.5 threshold. But in any case, that's something CORDEX might want to use, because since so much was being done at the 50 km level for RCP 8.5 and 4.5, we wanted to be part of that conversation and that development. But again, maybe these are things that CORDEX might want to think later. Now, we heard just now the number of ensembles. Under this project, SMHI has been the driver for many of the outputs that are come out. And we have actually, for the domain, thanks to SMHI and the work of our collaborating institutions, 13 completed outputs for this Arab domain, with other institutions also aiming to contribute as well, and we'll get down to that later. It is tricky, though, to bring these people together, and that's where CORDEX plays such an essential part. Inside an institution, you can set up your boundary conditions and the way you want to communicate. But when you bring in those other institutions to help increase the number of models, it's not so easy. Everyone has their own model, their own way of language, own way of storing, and this archiving issue has become a topic which I'll highlight a little bit later. But in the end, we do have ensembles that are generated both on for mid-year, mid-century, end of century, coming out with outputs, again, at the Arab level that allows that conversation to happen with our various stakeholders across sectors. For example, the difference between the 4.5 and 8.5 scenario showing the temperature changes. And all the core net CDF files generated with the work of SMHI have already been posted on the ESGF platform that is with nodes all over the world. The issue with this data set, this database, is that it's providing data in those climate research languages. A policymaker, I'm an economist, I'm a development economist and a lawyer, I'm not going to go up here and look at that information. What I need is digested projects, and therefore we are using this to help climate modelers access information and use that in order to do impact assessment work, but we are developing, therefore, another regional knowledge hub to provide them with the outputs that they need, somewhat like what was given the other presentation. In order to help that, though, and increase the number, we should really talk a little bit more, I hope, during this week about these CORDEX archive design protocols and how these are structured, what language. Because again, there's a lot of other players that are generating outputs, and we're not able to put them into the ensemble because of the disparate nature of all the information. So it's a shame that there's a lot of modeling work, but not a way to generate new ensembles, and we should work on that more. Again, at the request of the Arab states, there was a lot more interest over the last few years on the extremes and disaster risk reduction and Sendai. So we had another set of outputs generated with more detail, higher resolution at 25 kilometers, so that we would look at storylines related to more of the climate extremes. And what's interesting here is looking at the regional stories. Now, on Saturday, I had my family and I were at the beach at 40 degrees Celsius weather because I'm living in Beirut. I mean, thinking of myself coming over here with turtlenecks, I was surprised, I was concerned. But the issue when we're looking at the implications and the analysis, we can't only look at those standard way of thinking about what's a hot day and a cold day. If I looked in Lebanon and the Gulf that a summer day is whatever is above 25 degrees Celsius, it means nothing to me. That's almost all the days in the year. So what we did was identify different thresholds to make it responsive to what we need to know. And therefore, we have outputs, and we generated outputs from the modeling results for 35 degrees Celsius and 45 degrees Celsius, which makes more sense in our region. And that allows us to look at what are really the extreme temperatures, because 25 doesn't do it for us. 45, heck, in the Gulf, we're hitting 55 degrees in Iraq in the Gulf right now. But when you're above 45 degrees, I think it's well enough to understand that we're seeing that some areas are definitely much more sensitive to those heat stories. And not only the peaks, but also the consecutiveness of those peaks are being analyzed in our assessments. Rainfall, the same story. I mean, we're not looking at one threshold, but various thresholds over time. So just a lesson learned, we should not only look at the standard indicators that might be adopted, but look at those regional specific, and by region I mean the geographic region, that would make more sense for informing policymakers on discussion. So this is the slide I use often just to explain to the policymakers what we're doing. And this is as simple as we can get, but you have to realize that they are not going to get into the models and the names and whether it's REMO or RegCM. They're not going to care. They just want to understand it's a climate output, a hydro output, and something's going to give me a map. And the maps are really very useful. But there is a big confusion going on, this bias correction. And again, I hope this comes up during the course of the discussions, because what they see in those IPCC reports, non-bias correction, what we're using for the impact assessment studies, they are bias corrected. The numbers don't make sense. It's causing confusion with the policymakers and with the users of the data. So I hope we can find ways to maybe think about that more consistently in the future. And because we use this data not only for the RCM outputs, but for informing what's most important for the Arab region, which is water. I mean, if we don't think of the water story, it's irrelevant. It's not only temperature, it's not only heat, it's actually the water availability to make the economy and the human health continue. So we use this to inform regional hydrological modeling. For example, these are some outputs, and you can see that because of data and the ability to vet, it's not the Arab domain anymore, the MENA domain. It's another, we have to go where we have the data validated. And also we have subdomains that have been identified with more specific outputs, for example, runoff or discharge related to certain shared water systems or sensitive systems. This is where the science is really informed and linked then to the policymakers, because in each of the countries that have been active in this process, there's a focal point that helps us validate some of the information. Also, we have developed case studies that are demand-driven and also are able to access the specialities of our partner organizations. So we're working at agriculture and health as different ways of thinking. For example, we're using the climate models to better inform the prevalence of leishmaniasis, which is like a mosquito that makes like a scar on skin, especially for women in the fields and agricultural work and in agricultural fields in the region. And we are seeing that thanks to the models, we can sort of project what the impact might be. Is it more prevalent? What temperatures? And even where there might be less prevalence, when the heat becomes higher because those mosquitoes can't survive. So there's really focused application and utility for using these outputs for informing other work. Same with agriculture. My colleague here from AXAD is doing work with the FAO and with some German funds building on the CORDEX and RICCAR outputs to inform irrigated work, rain-fed, and other type of crop analysis based on the RICCAR outputs using aquacrop. And I'm going fast here because I know lunch is coming, but all this is then feeding into a socioeconomic vulnerability assessment. And this is the so what. Because the people, they're going to see, okay, I have more intensive precipitation, et cetera, but what does this mean for me and my community in my region? And therefore, we're building that in terms of informing a vulnerability assessment focused on key sectors identified through a consultative working group. We've identified 5 sectors: water, environment, agriculture, human settlements, and people that deal with even the labor components. And there's an impact chain of analysis, indicators that build on taking outputs from the RICCAR outputs for the exposure. And then basically in the end, training modules and training was provided, questionnaires for weighting and classification of the data was a very regionally engaged project. And basically these will be aggregated so that we come up with an identification of hotspots by the end of this year to share and help prioritize work. What's interesting is we want to ensure that full transparency of our work. So every indicator and every source of data is in a fact sheet that will be made available on a regional knowledge hub that was endorsed now under the League of Arab States with the support of a League and United Nations organization, which will provide not only the data, but the process data, the case studies, the training tools, so that it can be moved forward. And this, it was decided by resolution of the League of Arab States Arab Ministerial Water Council to set up this hub It will be coordinated by ACSED and ESCWA, but it will physically be based at something called Phoenix at the FAO in Rome, because it will allow us to not only post the data, but allow researchers to data mine and generate new maps upon demand with accessing the information. The prediction kind of the work is also being integrated into our work by the proposed setup of an Arab Climate Forum. Just last week was the first time that the ministers responsible for metrology in the Arab region met. It's always been a committee work. Metrology was never at the ministerial level when we thought about intergovernmental conversations. Just last week was the first time ministers met at that level, which shows the interest and the commitment to do a lot more work and capacity building in this area. WMO is a partner here, and they're going to be working to develop a capacity building plan to help build the capacity of Met services in this area. That said, there's been several numerous workshops and annual expert group meetings with our Met colleagues, our water colleagues, agriculture, et cetera, over the years to help them be engaged in this process. And in the end, this is informing our work through various consultative tools, annual expert group meetings, technical workshops, working group meetings, et cetera, to ensure that the region is part of this process. And in the end, this is informing a lot of work at the regional level as well as the country level on adaptation, negotiations. The UNFCCC communications, actually just on Monday, Lebanon was in our offices asking for outputs from the RICCAR to help inform their work, and of course, capacity building. So with that, I'd like to close by saying this work is coming to a head at the end of this year, and by the beginning of next year, the 10th anniversary of the Arab Climate Change Declaration. We hope to issue an Arab Climate Change Assessment Report that has the outcomes of all this work, and I'm hoping that the work of CORDEX can be integrated at that time, because while we are working on the intergovernmental process with the UN and League of Arab States and partner organizations, CORDEX has established in 2013, started in 2013, it was established in 2014, a MENA CORDEX working group headed by Panos at the Cyprus Institute. I haven't seen him yet today, but hopefully he's coming. And there's a host of institutions, 11 institutions committed to providing modeling outputs to that. But if they are just going to do climate research and we don't get it into the League of Arab States or the countries, and we meet them twice a year. Twice a year they're telling us we want to know about this, we want to know that. It's not going to wait for a peer-reviewed journal to influence the policymaker. The policymaker is going to want something, and they're going to want it within 6 months, not within the year and a half. So I hope that this connectivity between the research community and the policy community can be strengthened. We are waiting for these outputs for the journal or whatever data that we can put into the climate change assessment report and help to inform our partners and also the work of our respective organizations contributing. So thank you very much.
Okay. First of all, let me really apologize. I kind of lost track of time, and I realized that the last two talks have been somehow damaged by this. But if there are any questions, maybe we can take one or two questions. Yeah.
They want to go to lunch.
No, there is one here. Just, I think, sorry, Daniela, I apologize. I cannot say more than this.
Okay, just a very short question about the hydrological models you are presenting. When you show this area in which you really don't have projections, right, which is to the south of the main domain. I work with a lot of people of that area, and we always have this issue with data. South of the Chad Lake, there is no data whatsoever. My question is, in all of these political meetings, have you thought in, or the people involved have thought in helping those countries to get more data to actually see what happens with the models? We have a huge problem with convection there. We don't know how it works there. We have issues with the Congo River basin. So is there any chance to put more data on that area?
one of the first workshops we had was on climate prediction and climate projection with the WMO in Casablanca. And it was just specifically to get the Met services involved, not only the water services that have their own data sets, to see what is available. And in the end, they came up with a joint paper, and they were able to engage and share data amongst themselves for use in the models. What we found, though, because of the politics, we could not publish. They don't want us to publish that raw data on site. But they were not averse to providing the averages and the outputs. And actually, there's a journal, International Journal of Climatology article issued in 2013 that has some information from Mauritania and, from the countries that you might not have. There is information generated for the Arab domain for RCM. What we have the gap is the hydro data, because that really becomes even more sensitive. And that's where you saw the gap at the bottom of the domain. So we only hit the Arab countries where we could have at least something coming back from them in terms of data. But since we didn't vet, Ethiopia, or not Ethiopia, towards the said Chad, for example, it's not so much covered.
Okay, thank you very much. I think we're going to close here.